Okay, hello everyone. Today our topic is about rays and waves. Okay, and here we are moving to our first part is light rays and waves. Okay, so the first slide here is features of light. So as we all know that light is kind of radiation, right? So we can say that light is a form of radiation. And radiation have many kinds. We can say like the ultraviolet is a radiation, and infrared is a radiation, or like other kinds of waves. They are all radiation. Okay. So first we can say light is a form of radiation. Okay. The second part we can say light travels in straight line. So maybe you can find if you're using a torch, right? The light just moves just forward. Okay. So here maybe are some examples for the light features. Like here, if here are some light rays just instant at parallel lines. Okay. So maybe here we can find there are reflections on the paper, right? Like here reflected and here reflected, reflected and reflected. Okay. So this is why some people or some professor will tell you that maybe it's very maybe it's very not very good for your eyes when you're just looking the books under the sunshine, right? So that's because the paper is very not smooth, okay, like this way, and so we can maybe have reflected to everywhere, okay. So here we can say this is called diffuse reflection, okay. So that means reflection rays that just reflected into different angles and different direction, okay. And second, we call the regular reflection. That means that there's a rays right here and just shoot into the mirror and then reflect it back like this way. Okay, so we can say that here is a regular reflection. And another kind is called absorption. The absorption means that the ray is just shooting directly on black surface and it absorbed, right? Here is for the absorption. And another kind you can say is transmission, like here. We have a rays and just moving direct on the plane or plane mirror and then diffract, right? Like this way, okay? So we can call this transmission or refraction, okay? And here are other features of light. Like here, we can find first light transverse energy, okay? So I think it's very easy for you to understand because some laser beams, maybe you can use in the medical usages, like a doctor will use a laser beam to cut off like some cells or some like cancers using the laser beams. Or you can find some people have some beard, they want to share the beard, but it's very hard for them to share it every day. So they want to throw them away. They're using the laser beam to just moving on their skin, right? And their beard is away, right? Therefore, the light transverse energy. It can take energy on itself, okay? And the second part is that light can travel through empty spaces. So that is why the sunshine can just travel from the sun and to the empty spaces and then to the earth, right? So because ultraviolet and infrared can travel through the empty spaces, okay? And also, light is the fastest thing that during the vacuum. Like here, you know that light speed is 3 times 10^8 meter per second, right? And we can say that the fastest thing we have ever seen. Okay, there's nothing's speed is bigger than the light. Okay, and at last we can say light travels as a wave, so it has the same properties as the sound waves. Like you can diffraction, it can reflection, it can refraction. Okay, this is for the light waves. Okay. So here you can find, if you're just discussing about the light, here are some properties like here is peak, and here's trough, and here's a wavelength, and here is a amplitude. Okay. I also have to tell you a very different property for light. As we learned before, that the sound wave just use the vibration to transfer energy or travels in the substance, right? Like we said, that for sound in the solid, it can travel at a very high speed, right? So for sound or for mechanic wave, and this needs vibration. So we can say that the traveling speed is, or the highest traveling speed is in the solid, then in liquid, then in gases, right? This is for the speed. So that is because the first particle vibrate and will let second particle vibrate and make the third particle vibrate and fourth vibrate, right? So total substance, the vibrate will take another particle to vibrate. Okay, this is for the velocity for solid, liquid, and gases. Okay, this is for here. And maybe you can find liquid has particles are very far apart from each other and they have a very further distance, so they can just vibrate a little bit, right? And for gases, the particles distance is very far apart from each other. So that the gases vibrate, maybe it's less than in the solid and liquid. Or you can say that their transmission efficiencies becomes smaller and smaller. Okay, this is for velocity. Okay, and maybe we can say that for the light waves, or we can say electromagnetic waves. Okay, light waves or electromagnetic waves. We use EMW to represent for electromagnetic wave because the total word is very long. Okay, so for light waves, they're just a combination for electrical waves and magnetic waves. Okay, so it's just like a DNA shape, like a DNA spiral shape, like this way. Here's a DNA spiral shape, right, like this way. So the electric field just combined with magnetic field to travel it. So if they faced the solid, maybe they will think that, oh, here are a lot of particles inside of this. So for the EM waves, there are a much more restriction and like maybe for like a stone to block their way like this way. Okay, so like I said, the EMF when they're facing the solid, their speed is very small. Okay, but when they're facing liquid or even they are facing the gases, we can say that the barrier is become smaller and smaller, right? So for light waves, they're traveling faster in the air or in vacuum and bigger than in liquid and than in gases. Okay. So for air and vacuum, in IGCSE test, we consider their velocity equals to each other. It's already considered that the velocity is 3 times 10^8. Okay, air equals to vacuum because the particles is very far away from each other. So for gamma waves, the restriction is very less and they're just the same velocity. Okay, so this is for different features of light. So you can find, if you want to explain the difference between the light waves and the sound waves, maybe they're just from their basic understanding of the two waves. Sound waves is for vibrating to transmit the waves or propagation by vibrating, right? And light waves, just propagation by EM2 waves just becomes a spiral, right? And they are just moving towards, okay? This is for two waves, okay? And we can also say that the waves have different wavelengths and color. And here we can find there are some visible light, gamma rays, X-rays, ultraviolet, infrared, and radio waves. Okay, and you have to remember for this table. Okay, in IGCSE test we have this table to find the orders of the rays. Okay, so maybe in the next lesson we will learn why they're arranged in this way or why are their wavelengths from gamma rays increase to radio waves like this way, okay? Maybe here I have a brief introduction for you. And here for gamma rays, you can find the wavelength is very small, right? And in the last lesson, we learned that the wave have the ability of diffraction, right? Like this way. So we said that wavelength becomes bigger, the diffraction becomes bigger. And also, if the wavelengths become smaller, they're easily to go through the gap, right? And so they're like a particle, they're very small, okay, very easy to go through the gap, right? So for gamma rays, its ability is to penetrate. Okay, so for gamma rays, we can tell that, oh, because it's very small, so they can penetrate. So maybe you can find in some movies or in some medicals, where you're in hospital, you are using gamma rays to make your full body scanning, right? That's because gamma rays can penetrate through all of your body. And then for X-rays, because X-rays abilities may be smaller than gamma rays, because X-rays can only detect the bones, right? So we can say X-rays can penetrate your body, but it cannot penetrate the bones, right? So ability is smaller. That means the wavelength or like the size or like the bigness is bigger than the gamma ray. Okay. And for ultraviolet, in some movies, you'll find the police just using the ultraviolet to find some blood, to find some like the criminals. Like here's a hint for this, right? And ultraviolet can find the hints on the wall and on the floor. So we can say ultraviolet can also represent 4G signal. Okay, that means it can gives us an idea and give some hint, and it can also penetrate this signal. Okay, and then we said there are purple to red, right? This is for visible light. So ultraviolet is at this part. So for next part is visible light, and another part is infrared, right? It is ultra red, right? So you can say it's infrared. So after infrared, we goes to radio waves. That is because radio waves can traveling or it can take through the signal with it, right? So you can find in our city, we can receive the radio waves at any places, right? On your car, on your home, or even any places you can receive the radio waves, or even you're in the forest, right? That is because radio waves has a very big length. That means their diffraction ability is very big, right? Like this way, we have already discussed like before, like the particles just go through the gap, just like a very heavy person just going through the gap, right? So maybe here his body will become unshaped, right? Maybe like he will take in some oxygen and then hold his shoulder and hold his belly, right? And then go through the door. Okay, so we can say right here, the wavelengths very big. That means their diffraction ability is very strong. That means they can just go through the barrier very easily. So maybe in some cities, you will find here many skyscrapers, right? So for if you're using gamma rays and X-rays, you're taking the signal, maybe they will just maybe penetrate the buildings or skyscrapers. But their energy becomes very small. That is not very good for like taking some signals and taking some like some information for this. So radio waves can just pass through or using another direction to go through the skyscraper, but not just goes just move into the buildings. Okay, so it can uh, preserve the energy and preserve the signal and to take to your radios. Okay, this is for radio waves. That's because the wavelength is very big. Okay. So today is for our lesson, we have a basic understanding of light waves and rays. Okay, so see you next time. Bye.